Okay, so last time we established that GIS, Geographic Information Systems, well, it's way more than just a digital map.
Right. It's this whole dynamic system. It links location with information.
Mm-hmm.
Really powerful for solving spatial problems.
Exactly. So today the mission is to unpack the core components, the 5 essential pillars that hold the whole thing up.
That's right. Think of it like an engine. For it to run smoothly, reliably, you need all 5 parts working together. Hardware, software, data, people, and methods.
5 pillars. Okay, let's start with the foundation, the physical stuff. Hardware. This isn't your standard desktop setup, is it? Why so demanding?
Well, think about the computations. Spatial analysis can be incredibly intensive. You might be crunching millions, literally millions, of data points at once.
Like modeling water flow or finding the best spot for a wind turbine?
Exactly. So you need serious horsepower, high-performance servers to store all that data, and really powerful workstations, often with, specialized graphics cards, GPUs, to handle the processing.
And it's not just the computer on the desk. The hardware extends out, right? To the field.
Oh, absolutely. You need specialized input devices. Things like high-accuracy GPS receivers, much better than your phone's GPS, which can be off by quite a bit.
Okay.
And drones, too, for capturing detailed imagery. Then you also have output devices, like large plotters for printing big, high-resolution maps.
All right, so that's the muscle. What acts as the brain? That must be the software.
Precisely. The software is what lets you actually do things with the data. Store it, query it, run analyses, visualize it.
And a key part of that is the database system, the DBMS.
Yes, the database management system.
Yeah.
It's crucial. It's like the librarian that organizes all the descriptive information, the attribute data that's linked to the locations.
So it keeps everything tidy, whether you're using a desktop tool like, say, ArcGIS Pro or QGIS for heavy analysis.
Right, or if you're using web mapping applications to share information or even collect data out in the field on a tablet. The DBMS ensures it's all consistent and accessible.
Okay, hardware, software. Now, the fuel for this engine, data. You mentioned this is often seen as the most critical part and the most expensive.
Without a doubt. It's the absolute core. You could have the fanciest hardware, the best software, but if your data is bad, well, garbage in, garbage out, the whole analysis becomes meaningless.
Makes sense. And there are 2 main types of data we need to distinguish.
Yes. First, you have spatial data. That's the actual geographic coordinates, the geometry.
No.
Usually represented as points, lines, or polygons on the map.
Like the dot for a fire hydrant, the line for a road, or the shape of a property parcel.
Exactly. But just knowing where isn't enough. You need the attribute data. That's the what.
So for that fire hydrant point,
the attribute data would be things linked to it, like its installation date, its last inspection, its pressure rating. The spatial data gives you a location. The attribute data gives you context and meaning. They're inseparable, really.
Okay, that connects nicely to the next pillar, number 4, people. Because the tech is only as good as the folks using it, right?
Absolutely. It's easy to just think of the technical experts, the GIS analysts doing the complex modeling, or the cartographers making the maps look good and easy to understand. And they are vital.
But it's broader than that.
Much broader. You have the end users and the decision makers. Think urban planners using GIS reports to decide on zoning, or emergency responders using live maps during an incident. Their knowledge, their expertise in their own fields is what turns the data analysis into actual, actionable solutions.
So people apply the tech, but how do they ensure they're doing it consistently and correctly? That sounds like the last pillar, methods.
That's it. Methods are the how-to guide. The standardized procedures, the workflows, the protocols that govern how the GIS is used within an organization.
Like rules for collecting data?
Exactly. Standard operating procedures. For example, specifying how accurate the GPS readings need to be for a certain task, or requiring certain quality control checks before any map or analysis result is published.
Ah, so this guarantees the results aren't just a one-off, that they're dependable.
Precisely. It ensures consistency, reliability, and reproducibility. If you don't have solid methods, even good data can lead to flawed conclusions because the process wasn't sound.
Hardware, software, data, people, methods, all 5 integrated.
You take one away, the whole system falters or even collapses. You can't just buy GIS Insight off the shelf. It emerges from harmonizing all these components. It's truly an integrated system.
Okay, pulling this all together for you listening, we've heard that data is usually the most costly piece of this puzzle. So thinking strategically, what are the real long-term impacts for an organization when they choose specific methods, things like setting regular data update schedules or defining strict collection standards to manage not just the accuracy, but also the significant cost of keeping that essential data fuel clean and reliable? Something to think about.